This black powder has just 2 elements. But can you crack the code to its formula from just the mass? Let's break down how to find the empirical formula from the mass data. An empirical formula is a chemical formula that gives the smallest whole number ratio of elements in a compound. The empirical formula can be calculated from the mass data or from the percentage composition. But today, we're zooming in on the mass method. Here's a fun fact. Glucose's molecular formula is C6H12O6, but its empirical formula? CH2O. Yup, sugar's simplified twin looks suspiciously like formaldehyde. How is the mass method done? First, find the number of moles of each element. Then, divide the moles by the smallest mole number. Let's see some examples. Find the empirical formula of a 2.45 gram sample of which 1.78 grams is iron and 0.68 grams is oxygen. First, we calculate the number of moles of iron and oxygen from the mass data given. The number of moles of iron is equal to the mass given over the molar mass of iron. The mass given is 1.78 grams and the molar mass of iron is 56 grams per mole. 1.78 over 56 is equal to 0.03 moles. The number of moles of oxygen is equal to the mass given over the molar mass of oxygen. The mass given is 0.86 grams. The molar mass of oxygen is 16 grams per mole. 0.68 over 16 gives 0.04 moles. Then we divide these moles by the smallest mole number. The smallest mole number is 0.03, the mole of iron. The ratio of iron is equal to the mole of iron over the smallest mole. The mole of iron is 0.03. The smallest mole is 0.03. 0.03 over 0.03 gives 1. The ratio of oxygen is equal to the mole of oxygen over the smallest mole. The moles of oxygen is 0.04. The smallest mole is 0.03. 0.04 over 0.03 gives 1.33, which is just 1 mole. Therefore, the empirical formula of this compound is Fe1O1. This is further written as FeO, the chemical name for iron 2 oxide. Another example. The unknown compound is found to contain 13.5 grams of calcium, 10.8 grams of oxygen, and 0.68 grams of hydrogen. Calculate the empirical formula of this compound. First, find the moles of each element from the mass given. Then we divide the moles by the smallest mole number. The number of moles of calcium is equal to the mass given over the molar mass of calcium. The mass given is 13.5 grams. The molar mass of calcium is 40 grams per mole. 13.5 over 40 gives 0.34 moles. The number of moles of oxygen is equal to the mass given over the molar mass of oxygen. The mass given is 10.8 grams. The molar mass of oxygen is 16. 10.8 over 16 gives 0.68 moles. The number of moles of hydrogen is equal to the mass given over the molar mass of hydrogen. The mass given is 0.68 grams. The molar mass of hydrogen is 1. 0.68 over 1 gives 0.68 moles. The smallest mole number is 0.34, the mole of calcium. So we divide moles by 0.34. The ratio of calcium is equal to the mass of calcium given over the smallest mole. The mole of calcium is 0.34. The smallest mole is 0.34. 0.34 over 0.34 gives 1. The ratio of oxygen is equal to the mole of oxygen over the smallest mole. The mole of oxygen is 0.68. The smallest mole is 0.34. 0.68 over 0.34 gives 2. The ratio of hydrogen is equal to the mole hydrogen over the smallest mole. The mole of hydrogen is 0.68. The smallest mole is 0.34. 0.68 over 0.34 gives 2. Therefore, the empirical formula of this compound is Ca1O2H2. This is further written as Ca-OH-2, the chemical formula for calcium hydroxide. To recap, an empirical formula is a chemical formula that gives the smallest whole number ratio of elements in a compound. To find the empirical formula from the mass data, first, find the number of moles of each element. Then, divide the moles by the smallest mole number. From rust to bleach, empirical formulas are the silent blueprints behind everything we touch. Learn to decode them, and you're not just reading formulas, you're reading the language of matter itself. Now that you've cracked empirical formulas from mass data, next up, empirical formulas from percentage composition. Stay tuned. Stay curious.